So ladies and gentlemen, here is the last example on page 20, example 3C. So again, we're looking at our definite integral going from 1 to 4 of dx over x minus 2 to the 2/3. So again, one thing now that you have, anytime you see a definite integral, what you're going to have to now look at is see if there's a place between your lower bound and upper bound that would make your function undefined. So notice when you've got x minus 2 in the denominator at x equals 2, we know that this function would be undefined. So this is what we call our integrand is infinite because we have that vertical asymptote there. That's where we're undefined. So when you've got your definite integral and you've got a value between your lower bound and upper bound, you have an improper integral. So let me first, before I split this up, let me just go ahead and integrate this particular integral. So again, I know I'm going to have to do a u sub. U is equal to x minus 2. My du is going to be equal to dx. So again, I can rewrite this as u to the negative 2/3 du. So then I'm going to be able to integrate this. Again, that's going to be u to the 1/3 divided by 1/3, which is 3. So again, I end up with 3 times x minus 2 to the 1/3. So now what I need to do is I have to split my integral at x equals 2. So I have, again, my integral going from 1 to 2 dx over the quantity of x minus 2 to the 2/3. So when you've got this bound, as you remember from the previous example, at this bound we're undefined. So I'm going to replace it and I'm going to find the limit. Since this is my upper bound, I want to find the limit as we're approaching 2 from the left. So I'm going to write this as the limit as k is approaching 2 from the left, again from 1 to k, of dx over x minus 2 to the 2/3. Again, I've already integrated this, so this is going to be equal to the limit as k approaches 2 from the left of 3 times x minus 2 to the 1/3. And again, I have to evaluate this from 1 to k. So again, I've got my constant of 3 that I'll pull out. Again, the limit as k is approaching 2 from the left. When I do my direct substitution, I know that 2 minus 2 is going to give me 0, and 0 to the 1/3 is 0. Minus. Now I'm going to plug in my lower bound of 1. 1 minus 2 is negative 1, and the cube root of negative 1 is negative 1. So then I know the limit of this integral is going to be positive 3. 3 times positive 1 is 3. So now what I'm going to have to do is I'm going to have to take this and add it, again, because I'm going to split this at 2. So my lower bound is now going to be my 2, and I have to integrate from 2 to 4 of dx over x minus 2 raised to the 2/3. Since my lower bound is where it's undefined, I want to find the limit as we're coming from the right of 2. So I'm going to rewrite this integral as the limit as k approaches 2 from the right, from k to 4. Again, I've already integrated this, so I have the limit as k approaches 2 from the right of 3 times x minus 2 to the 1/3. And again, I'm going to evaluate this from 4 to k, or from k to 4. So I'm going to keep that 3 factored out. I'm going to plug in my 4. So I have 4 minus 2, which is 2, so I have 2 to the 1/3. Minus. Plug in, again, the limit as k approaches 2 from the right. I'll do my direct substitution. 2 minus 2 is 0, so that's going to go to 0. So I end up with 3 times, again, 2 to the 1/3 is the cube root of 2. So then what I need to do is I need to take these two and add them together. So 3 plus 3 times the cube root of 2 is my final answer. So this would converge.